Let's begin with computing future values of lump sums with both simple and compound interest. So a lump sum again is a single amount, and simple interest is interest per period that is computed on the original principal. So if we wanted to know the future value of $100, and that's the principal, invested at 10% simple interest for 1 year, we could draw a timeline where 0 is today and the 1 is 1 year from today, and we have $100. That would be, we call that the present value or the principal that we've invested, and in 1 year at an interest rate of 10%, well, 10% of $100, we would have interest of $10. And then we'd also have our original $100, so that our future value would be equal to $110. But what if we wanted to know for a longer period of time? So what is the future value of $100 invested at 10% simple interest for 3 years? Well, we'll draw the timeline here. For 3 years, 0, 1, 2, and 3, we have our present value or principal of $100, and we have a simple interest rate of 10%. Well, in the first year, we earned simple interest of $10, 10% of the original $100. So our future value, I'll put a little subscript there, at the end of the first year, as we saw before, was $110. In the second year under simple interest, we would earn another $10, 10% of the original $100, so that our future value at the end of year 2 would be, well, the 110 that we had before at the end of the first year, plus another $10 in interest earned, we'd have a future value in period 2 equal to $120. And then the third year, we'd earn another 10% on the original $100, or another $10 in interest. We add to that the $120 future value from the previous period, and then we would have a future value in year 3 equal to $130. And if we wanted to know the future value of $100 invested at 10% simple interest for 10 years, well, we're getting quite a few years here. Let's look at this in a spreadsheet. So looking at this in a spreadsheet, we have our principal or present value of $100, interest rate of 10%, type of interest is simple. So at time 0, we have a present value of $100, and then after the first year, applying our 10% simple interest to the original principal amount. And if you look right up here, you can see the formula, which is simply $100 C6 plus the principal amount 100 times 10%. And in the second year, we're also earning 10% on the original $100, and then we're adding to that the value that we had at the end of the first year, so just as we saw before. So each year we're earning 10% interest and adding that to the previous year's balance. So as you can see, the future value is increasing by $10 each year. So if we were to look at that on a chart where the number of years is on the horizontal axis and the future value is on the vertical axis, we can see that with simple interest we have this nice linear relationship between time and future values. We can also move money in time using compound interest. And compound interest is interest that is earned on a given deposit and has become part of the principal at the end of a specified period. So if we wanted to know what was the future value of $100 invested at 10% compounded annually for 1 year, in our timeline here, a compound interest rate of 10%, a present value or principal of $100, and applying that 10% interest rate to our original principal of $100 gives us a future value of, well, how much interest have we earned? $10, 10% of the $100, plus the original $100, gives us a future value at the end of the first year, sorry, can't write, $110, which was exactly the same as what we had with simple interest. But things begin to get different with compound interest when we have longer periods. In other words, when we have more than one period. So let's look at it after 3 years. So again, we would have our $100 present value, a compound interest rate of 10%, and at the end of the first year we would earn $10 in interest. So our future value would be equal to the $10 plus our beginning $100, or $110. And that $110 becomes the new principal that compound interest is computed on. So in year 2, we're going to earn 10% of the $110. In other words, $110 times 10%, we would earn $11 in interest now, 10% of the $110. We add to that the $110 that we had at the end of the first period, and at the end of the second period, our future value at the end of the second period is $121. And then in period 3, we're going to apply that 10% on the 121. So the interest that we would earn would be $12.10, or 10% of the $121. We add to that the future value at the end of the period 2, our account balance at the end of the period 2, and adding that together we would have $133.10. And if we wanted to know what the future value would be of compound interest rate of 10% of $100 invested over 10 years, you got it. Let's go back and let's look at that spreadsheet. So before we calculated in the spreadsheet our simple interest rate of 10% on original principal amount of $100, and we calculated the simple interest, and we saw that it was simply $10 per year. Now let's take a look at compound interest. So for the compound interest and the simple interest, after only one period, the future values are the same. But we begin to see a difference after the first year, because with compound interest, we're earning interest on the previous account balance, which included the principal plus the interest that was earned. Whereas with simple interest, we're only earning interest on the original principal. So at the end of the second year, applying 10% to the $110, we come up with a future value of $121, and we earned $11 in interest. In the third period, we earned 10% interest on the preceding balance of $121. That gave us a future value of $133.10. And we continue that for each year. And as you'll notice, that as we go through time, there's quite a bit of difference showing up between the future values of simple interest and compound interest. So we calculate the differences. So in the first year, not any difference. And after 2 years, there was $1 difference in future values. Compound interest rate had a future value after 2 years of $121. Simple interest was $120. So it's an interest difference of $1. Future value difference at the end of the third year was $3.10. And the interest difference at the end of the fourth year was $6, and we continue that. So by the 10th year, the difference in future values is pretty large, $59. Now, if we look at the year-over-year differences, so we grew, the difference between compound interest and simple interest was $1 in that second year. That difference between compound interest and simple interest from $3.10 to $1, that grew by $2. And for the fourth year, going from $3 to $6, that's a difference of $3.31. And in the fifth year, going from the value in the fourth year, $6.41, to the value in the fifth year, $11.05, that's $4.64. Can you see that the the differences are getting larger and larger and larger. So it doesn't appear that we have a linear shape. So if we look at the chart to compare simple interest versus compound interest, now before we had that straight line. With simple interest, we have a linear relationship between time and future values. But once we have compounding interest, because we're earning interest on interest, we no longer have a linear relationship. In fact, we see this sloping up, and that over time, the difference between compound interest and simple interest gets larger and larger and larger. The general equation for a future value at the end of period N is the future value is equal to the original present value multiplied by 1 plus the interest rate R raised to the number of periods. Now we could see that when we, for example, were calculating the future value of that $100 invested at 10% compounding for 3 years. The future value would be equal to the $100 multiplied by 1 plus that 10% interest rate for the first year, multiplied by 1 plus the interest rate for the second year, multiplied by 1 plus the interest rate for the third year, and we came up with $133.10. So that is equivalent to a future value of $100 multiplied by 1 plus the interest rate raised to the power of 3, which is our equation that we have here for the future value. So we call this compounding. We're finding the future value of some present value at some interest rate. This is our compounding formula. So for example, Jane places $800 in savings, paying 6% interest compounded annually. She wants to know how much money she will have at the end of 5 years. Well, that future value, applying our future value formula, present value multiplied by 1 plus the interest rate raised to the number of periods in is equal to $1,070.58. And if we look at this on a timeline, we are compounding this $800 1, 2, 3, 4, 5 periods to a value of $1,070.58. We can also use Excel spreadsheet or a financial calculator. When it comes to financial calculators, you can purchase a standalone calculator. I like to use the Texas Instrument BA2 Plus. Details of that are in the syllabus. Or you can purchase an app for your phone or tablet that has a time value of money function on it as well. Because we have the exponent n, we call compounding an exponential function. Present values grow at an exponential rate. And this has implications for not only n, the number of periods, but also for differences in interest rates. As we saw, this exponential growth function of compounding causes, over time, larger and larger difference between compound interest and simple interest. So in compounding, we know that over time, because of the ability of compound interest, because compound interest earns interest on interest over time, we have that exponential growth rate, that time matters, but also different interest rates matter as well. So for example, let's look at what happens to our $100 invested at 10% interest with compound interest. Notice here at the end of the first year, if we have 1% interest per year, the future value would be $101. If we had 5% interest per year, the future value would be $105 after 1 year. If we had 10% interest per year, the future value after 1 year would be $110, and so on. Now let's look at what happens at year 5. At year 5, the future value at 1% is $105.10. The future value after 5 years at 5% compounded interest, that is $127. At 10% at 5 years, that's $161. And 15%, that is $201. So if we were to compare the difference between future values at 15% and future values 5%, we would have this, the difference between 15% and 5%. And we can see that over time, the difference between interest gets larger and larger as well. So as we're applying more interest over longer periods of time, that compounding, that exponential function, increases future values more. But no matter what interest rate, let's just look here at year 10. At year 10, the difference between 5% interest and 15% interest has a difference of future values of $241. And if we look at the year-over-year difference, for example, 196 to 241, that's 45, we see that getting larger and larger as well. Now, notice though that in year 10, when we're calculating future values, the higher the interest rate, the higher the future value. And you may say, well, gee, that's not exactly rocket science. And you're right, it's not. But notice how the difference between, say, 5% and 15%, how large it is in year 10 versus how large it is in 20 years. 265 versus 1,636. A very huge difference, a difference of 1,375. We can also use Excel to calculate future values. So directly, if you look up here, you'll see there's a function called FV, which is future value, where we plug in the number of periods, the interest rate, and the present value to arrive at a future value. Looking at the differences on the chart may be more illuminating. So we can see that over time, no matter if we have 1%, 5%, 10%, or 15% interest rate, we have an increase in future values over time. And although you really can't see it here on the 1% line in the blue, it is also not a straight line. You can kind of get a little bit better feel for the 5%. And the reason for that is with higher interest rates, we contribute to the interest on interest effect more and more. So you can see the difference between 10% interest and 15% interest over 20 years. That's a huge difference. Over 1 or 2 years, it doesn't appear to be that much. But because the way compounding works, earning interest on interest, differences in interest rates matter more and more over time. This is why if you're young and you can get into a savings plan, invest early over 20, 30, 40 years, compounding is your friend because you earn interest on interest, and that really piles up. You can see how in the later years this line looks like it's almost getting ready to go vertical. That's wealth creation over long periods of time. This is why you want to start saving early so you can get into this region right here, rather than starting late and starting off in that region.